Alright viewers, this is Educom with Ajibola, and just like I promised in the last session that I'm going to make justice to the topic we have on board, which is hydrogen ion concentration and hydroxyl ion concentration. But in short, we can call it pH and PoH of a solution. Now, basically, when we hear about pH, so many students will feel like I'm having issues with pH, so I really do not understand the term pH. pH just has to do with the degree of concentration of the acidity. It's the measure of the degree of concentration of acidity, while pH is the measure or degree of concentration of hydroxyl ion concentration. So now basically when we talk about pH has its own measuring scale, and the measuring scale varies from 1 to 14. So where we have 1 to 6 as the variance for acid or for acidity, while 7 is neutral, which is water. Water is a universal solvent, of course, while from 8 down to 14 happens to be the alkalinity, which is the basicity of every hydroxyl ion concentration. So today, let's start with this example. The question on board is saying that the hydrogen ion concentration, which is H plus in a solution, is 5 times 10 raised to power minus 3 moles per dm cube. We can otherwise call this or refer to it as 5 times 10 raised to power minus 3 molar. So what's the question asking us to do? The question is a question that will determine the pH of the solution. So the first thing we need to do here is to understand that since we are looking for the concentration of the acidity, definitely in every acid, just like I would always tell my students, if we have something like HCl, if HCl, hydrochloric acid, would get to dissociate, it will dissociate into H plus and Cl minus. So it means that this shows the power of the protonation of the hydrogen ion concentration. So same thing happens there in H2SO4, tetraoxosulfate 6 acid. It also happens in HNO3, and every case like that, be it CH3, COOH, which is the ethanoic acid. So let's move on. The first thing we need to do, okay, solution. So the hydrogen ion concentration in this scenario, which is H plus, this bracket here means concentration. The hydrogen ion concentration here is 5 times 10 raised to power minus 3 moles per dm cube. Now, just like I said, we can get to refer this or call this molar. 5 times 10 raised to power minus 3 molar. We can also call it, or we can get to rewrite this instead as mole dm minus 3 raised to power minus 3. So now let's move on. pH has its own simple formula. Here in this case, the simple formula is pH is equals to minus log base 10 then hydrogen ion concentration. This is the universal formula for calculating pH, while that for PoH would be PoH plus pH is equals to 10 raised to power minus 14. So moving on with what we have here currently, now the next thing here is to fix in 5 times 10 raised to power minus 3 into this column where we have H plus or H raised to power plus. Then I have this as pH is equals to minus log base 10 open bracket 5 times 10 raised to power minus 3 molar. Now, I hope we all get it up to this point. So the next thing we really need to do here is to introduce the law of logarithm. The law of logarithm simply states that when we have multiplication, we can fix it in as plus. Please take note of it. It is one paramount thing here because we are dealing with logarithm law here. Meaning the fact that we are having log base 10. So me doing that or me introducing the law of logarithm, that would make me differentiate them. I need to split them up. So therefore, I have this as minus log base 10 5, then plus log base 10 raised to power minus 3. So please look up everyone and tell me, hope there's no way you're having issues or difficulties as regards to this. So now, after this, the next thing we need to do from this point is that we also need to understand that log 10 base 10, this and this would cancel out. So log 10 base 10 would give us 1. So here, what I have here is I have 1 because log 10 base 10 would cancel out. So then I have this as minus log base 10 raised to power 5 or log base 10 5 plus. So this is now 1. It's no longer occurring as log 10 base 10. So this is going to be the minus 1 times what? Or let's write it as 1 times 3. Please look up everyone. I hope we are getting this right. So okay, it's going to be minus 3 because of this. This is definitely going to affect it. Now, from this point, the next thing we really need to do here is that 1 times 3 is going to give us what? It's going to give us 3. So let's put in our brackets. So that's going to be minus log base 10 5 then plus 1 times 3 is what? Minus 3. So now please do not forget this. So now let's further move. That's going to be minus log base 10 5 minus 3. So it means that this minus I have here will definitely multiply everything I have there in the bracket. So now following this is going to give us minus times log 10 raised to log base 10 5. That's going to definitely give me minus log 10 base minus log base 10 5. So let me write it out because we need to eliminate this bracket from this point. So I have this as minus log base 10 5. Then minus times minus is going to give me what? Plus. So I have plus 3. Please look up everyone. I have plus 3. Now we need to understand certain logarithm constants such as log 3, what is log 5, and what is log 2. So here now log 5 would give us 0.6990 if I'm not wrong. So definitely I have this as minus 0.6990, right? So plus, now let's see it now. So that's going to be plus 3. So now this plus this, that's going to give us, please look up, that's going to give us 2.30. Now how do we get to confirm that our answer is correct? We can only get to confirm that our answer is correct going back to the diagram. I told us that the pH range varies from 1 to 14, where 7 happens to be neutral. So it means that 1 to 6 is acidity, is acid, while 8 to 14 is base. So now, since we are looking for pH, which is the degree of acidity in that solution, so what this is saying in essence is that this here is between the range of acidity, because 1 to 6 signifies or denotes acidity. So thank you, and definitely in our next class, I'm also going to be breaking other concepts down so every one of us can understand and all relate to what chemistry is all about. So join me as we make chemistry exciting once again. See you in our next class.